Hello, my name is Idil and I'm a Year 9 student at the British International School of New York. And I conducted a project on how we can create cheap and hand-powered alternatives to centrifuges and microscopes to help diagnose bloodborne diseases in developing nations. When used for disease testing, a centrifuge separates blood components and makes pathogens easier to detect. Typical centrifuges can cost anywhere from $1,000 to $5,000 upwards and require electricity, which makes them impractical in rural areas with no electricity and poorer regions that cannot afford them, where the diseases are most prevalent. However, using a button and string, we can create an efficient and portable alternative. With rotational speeds of up to 100,000 revolutions per minute and forces of up to 30,000 times greater than that of gravity, the device separates blood plasma from red cells from blood pathogens in less than 5 minutes without electricity and can be manufactured for less than 20 cents. The microscope is another key element in the identification of pathogens. However, much like the centrifuge, costs too much to be used in rural areas. But using cardstock and a magnifying lens, I used a sapphire ball lens with magnification capabilities, we can create a 2D microscope that is just as powerful as a lab microscope. We can also create our own slides with cardstock and clear tape. With the paper microscope, centrifuged blood samples can be turned into slides and observed under the microscope. These are the results for the paper microscope. The first image is a sample of uncentrifuged blood, therefore you can't see the individual cells. However, if it was centrifuged, you would be able to see them. The second image is a hair sample, and the third image are some flower cells, all underneath the paper microscope. These were the results for the buttonfuge. The first image is the blood before centrifusion, where the red blood cells and the plasma are mixed. The second image is the result after 2.5 minutes in the buttonfuge, where there is a clear separation in the plasma and the red blood cells. In conclusion, I had set out to create cheap and hand-powered alternatives to basic medical equipment, and throughout my project, I have now found that we can diagnose bloodborne diseases like malaria and HIV for less than $1 and without electricity.